Hello my dear students, this is the video material for Engineering Mathematics 1 and also Mathematics for Information Technology 1, as most of the course material is the same for you both. I will upload the videos into separate playlists, so you will always know whether this is for you or this isn't for you. In today's videos, we will solve all the exercises that were solved in the practice today. So let's get to it. The numbers are correspondent with the ones on the exercise sheet, which you can find in your Teams groups. The first exercise is a true or false exercise, as you can read it. It's exercise 1a. Here we have to determine whether square root of 2 belongs to this set or it doesn't. So the order of the operations is the same at the set operations. It's exactly the same in arithmetics and set operations in a way that parentheses are always the first step we have to tackle. So we will calculate this set and we will calculate this set and see how we can move forward with it. So the first one, the complement of the empty set with respect to the real number set, of course, intersection the complement of the rational number set with respect to the real numbers. Now the complement of the empty set with respect to the real numbers is the set of real numbers, and the complement of the rational numbers are the irrational numbers, so q plus or q star, or just mark it however you see fit. Now I'm looking for those numbers that are both real and irrational, and these are the irrational numbers. So the first parenthesis contains the irrational numbers. Let's see the second parenthesis. So this is the real numbers intersection rational numbers. I'm looking for those numbers that are both real and rational, and these numbers are the rational numbers. So this is in the second set of parentheses. So we have q star minus q. Now I'm looking for those numbers that are irrational but not rational, and these numbers are the irrational numbers. So the question which we need to answer is it true that the square root of 2 is an irrational number? And this statement is true, and we have shown the reasoning behind it. So this was exercise 1a. Next up we have exercise 1c. Is it true that the 2 is a member of the following set R intersect and complement with respect to the real number set? Well, let's see. The intersection of the real numbers and the natural numbers are the natural numbers, as natural numbers are a proper subset or real subset of the real numbers. So far so good. Now, what is the complement of the real numbers? Sometimes the answer cannot be written down with one single symbol, and this is such case. You see, the natural number set's complement is, well, the numbers that are not natural. This is my answer. The not natural real numbers are in this set, or I could write non-natural numbers, and so on and so on. You get what I mean. Now, let's see. Is it true that the number 2 is not natural? Well, Of course, it is not. The number 2 is in fact a natural number, so this statement is false. Next up, is it true that the square root of 2 is not an element of this set, which is z complement with respect to the real numbers minus q? Well, let's see. Sometimes it's easier to figure out the answer if we see a drawing, a picture. Well, let's see. My universal set now, as usual, is the real number set, so I must sketch this one. The interesting sets are the integer numbers and the rational numbers, so these are some other sets I will draw, and I don't care about the rest of the sets, so I will not draw them. The Z complement will be blue in my picture, so you can see everything but Z. Some rational numbers, some real numbers, but no integers whatsoever. So this blue hollow rectangle is the Z complement set. And I have to exclude the rational numbers from it. This will be red, so no rational numbers out of this blue area, which leaves us with some real numbers which are not rational. And we have previously learned that those numbers which are not rational are the irrational numbers. So this Z complement minus Q equals to the Q star or Q plus set, the irrational number set. Now the question is it true that the square root of 2 is not an irrational number? But while the square root of 2 is an irrational number, so this statement is false. Our last exercise from this group is it true that if I take a rational number and an irrational number, then their product will be rational? Now, we usually have a hunch with these kinds of exercises, and my hunch is that this is not true. Now, for a statement to be false, it is sufficient to give one counterexample. So if I can come up with a number that is rational and the number which is irrational, and their products are not rational, then this statement is false. And this is what I will do. So for number A, a rational number, I will choose 2. That is rational. So far so good. For B, I will choose, let's see, pi. Why not? Pi is an irrational number. The question is 2 times pi rational or irrational? And this is an irrational number. So I have found one counterexample. This means that this statement, this one here, the top row, is false.